block elements. Basically, let's just take a recap. We classified the entire periodic table into 4 blocks: S block, P block, D block and F block. The S and P block, they are collectively known as representative elements or normal elements, right? The D block, they are known as transition elements, and the F block are known as inner transition elements. Now yesterday we did was that when we are talking of the S block elements, the S block elements, they have only 2 groups, and they are the alkali metals and the alkaline earth metals. We did the characteristics of S block elements yesterday, so today we are going to do the characteristics of P block elements. In case of P block elements, the general electronic configuration, that is going to be Ns2Np126. Right? So we can see over here that the subshell P is filled, Np you can write, is filled progressively. So in the P block, there are going to be how many elements? There are going to be 6 groups which are present in the P block. Starting from, there are 6 groups in the P block, starting from group 13 with general electronic configuration of Ns2Np1, group 14, Ns2Np2, 15, Ns2Np3, 16, Ns2Np4, 17, Ns2Np5 and 18, Ns2Np6. Right? Now over here group 13 is known as the boron family. After the first member of its group, group 15 is known as the carbon family. Group 15 is known as the nitrogen family. 16, that is known as chalcogens. Chalcogens means ore forming. So group 16 has oxygen and sulfur as the first and the second element, and most of the ores, they are found in the form of oxides and sulfides. Okay? Group 17, they are known as halogens, and group 18 is known as the noble gases. Right? So this is what we are going to study under group the P block elements. The P block elements is also known as representative elements or normal elements. Okay. Then we go on to the characteristics of P block. Characteristics of P block. The first characteristic is that except fluorine and noble gases, the P block exhibit variable oxidation states. Oxidation states from plus N to N minus 8. Plus N to N minus 8. For example, if you are talking of lead, lead shows us oxidation state of plus 2 and plus 4. Similarly, tin shows variable oxidation state of SN2 and SN4 positive. Right? So they show variable oxidation states. Similarly, when we are talking of oxygen or we are talking of chlorine, chlorine gives us oxidation states starting right from -1 to +7. Example which we can take over here is that of HCl, where the oxidation state of chlorine is -1, whereas Cl2O7, where the oxidation state of chlorine, that is +7. Right? So number of oxidation states, they are shown by the p block except for fluorine and noble gases, where fluorine only shows -1 oxidation state and noble gases shows generally an oxidation state of 0, valency of 0. Okay. Then the second characteristic is that the p block generally shows covalency. That is, they form covalent bonds, but their higher members, they may show electrovalency, right? But the higher members show electrovalency. Means they form electrovalent bonds. Right? So lower members, they show covalency, but the higher members may show electrovalency, as in the case over here when you are talking of lead over here. So lead comes at the bottom of group 14. So it can form ionic compounds. But when we are talking of carbon, carbon can only form covalent compounds. Okay. So let's just take an example. If we are taking carbon family, we have carbon, silicon, germanium, tin and lead. Over here, carbon only forms covalent compounds, silicon, germanium, they all form only covalent compounds, whereas tin and lead, they have the tendency to form ionic compounds also, as in the case of SnCl2 and SnCl4, and similarly PbCl2. Okay, so higher members, they can show this thing, electrovalency. Now electrovalency also they will show with highly electronegative elements only, like for example over here fluorine, it is showing electrovalency. Similarly fluorine, compounds of fluorine with the p block, they can form ionic compounds. Oxygen also has a tendency to form ionic compounds. So these are all higher members, right? Then next, when we are talking of the p block, in period from left to right, non-metallic character will keep on increasing. So we are saying that in the p block, from left to right, non-metallic character increases, right? Whereas when we are going down from top to bottom in a group, from top to bottom, metallic character increases. Metallic character, that is going to increase. So if we are traveling from left to right, that is we are going from boron to fluorine. So fluorine, that is going to be the most non-metallic element of the periodic table. Okay, whereas when we are going down the group, as we are going down from carbon to lead, so metallic character, that is going to increase. Okay, so this is another characteristic. Then ionization energies increase from left to right, whereas ionization energy decreases from top to bottom, right? So ionization energy increases from left to right, whereas it decreases from top to bottom. Now when we are talking of any p block element has both reducing as well as oxidation properties. Therefore we say in every period reducing nature decreases. Reducing character decreases a longer period, right? That means when we are traveling from carbon to fluorine, fluorine is, we have also done, we would be doing in your electrochemical series, that fluorine, that is the best oxidizing agent. So if you're traveling from left to right, the reducing character is decreasing, whereas oxidizing character, or you can also put it this way, that reducing character increases down the group. So as we are going down the group, the reducing character, that is going to increase. Okay, now most of the elements of this are highly electronegative. So the next characteristic, most of the elements are electronegative in nature, and the electronegativity increases along the period and decreases down the group, right? So as we keep on traveling along the period, the electronegativity will keep on increasing, and when we are going down the group, the electronegativity keeps on decreasing, right? Then after electronegativity, we say that most of them, because most of them they are going to be non-metals, so most of the oxides of P block are acidic in nature. This is important. Are acidic in nature, right? So because most of them we would see they exist as non-metals, and non-metallic oxides, they are always acidic in nature, whereas metallic oxides are always basic. So because P block consists of majorly non-metals, therefore their oxides, they are going to be acidic. Okay, then most of the elements of P block show the property of allotropy. Now what do we understand by this term allotropy? When one element exists in more than one structural forms, that is allotropy. When one element exists in more than one allotropic forms or more than one structural forms, that is known as allotropy. For example, when we are talking of carbon, carbon has 3 allotropes. The first one, that is graphite, diamond, and the third one is fullerenes, right? So this is allotropy. Many metals they show allotropy. For example, carbon, silicon, phosphorus, sulfur, boron and germanium. They all show allotropy. And then there is another very important property which the P block exhibit, the property of catenation. Catenation means self-linkage. The elements of the P block have the tendency to form bonds with itself. That property is known as what? It is known as catenation. Clear? Now you know that carbon forms long chains in organic compounds. So carbon has the property of catenation. Then we have silicon. Silicon is also has the property to self-link with itself. Then nitrogen. All these elements, they have the property of catenation. And also germanium is another one. Right? So this is the P block and the characteristics of P block elements. Let's go on to the next block of elements which is known as D block. Next block is D block. The D block elements, the d block elements, they are also known as transition elements. Transition elements. In this case, progressively the n minus 1d is filled. N minus 1d, that is filled, and this n minus 1d subshell, this is known as the penultimate. This is known as the penultimate subshell, right? The electronic configuration of this varies from n minus 1 d1 ns2 to n minus 1 d10 ns2. So this is how we are going to progressively fill the d block over here, or the d subshell over here. Okay, now these elements, they are known as transition elements as their properties progressively change from S to P, right? They are placed in between S and P, and their properties are also intermediate between S and P. Okay, therefore they are known as transition elements. Now basically when we are defining the transition elements, all elements having incomplete d orbital in neutral atom, neutral state, or its most stable oxidation state. Most stable oxidation state, that is the d block. Okay, just for example, if we are taking we are taking scandium, right? The outermost electronic configuration of scandium, that is going to be argon 4s2 3d1. This is how we are going to write the electronic configuration. So you can see over here that 3d1 means it has an incomplete electronic configuration for D. Okay. Similarly, if we are taking, let's take any other, let's take iron. The atomic number of iron is 26. So electronic configuration, that is going to be argon 3d6. Again, the 3d over here, that is incomplete. The only three elements which do not follow this definition, they are zinc, cadmium and mercury. Zinc, cadmium and mercury do not follow the above definition. Like for example, we are taking the electronic configuration of zinc, it is argon 4s2 3d10. So in this case, it is complete electronic configuration, and the most stable oxidation state of zinc, that is Zn2 positive. So here also argon 4s0 3d10. This is the electronic configuration. But still zinc is taken under D block. Zinc, cadmium and mercury, they are taken under the D block because they fall as the last members of the series. So they are studied under the D block, right? Otherwise they do not fall under the definition of D block. Then all the transition elements are heavy metals. All the transition elements, they are heavy metals. And the elements, they are classified into 4 series. The elements, they fall into 4 series. The first series in which 3D is progressively filled, that is known as the 3D series, and the members of the 3D series start from scandium with atomic number 21, right? And then titanium, 22, vanadium, 23, chromium, 24, manganese, 25, iron, 26, then after that is cobalt, 27, nickel, 28, copper, 29, and zinc, which is 30, right? So this is the 3D series in which we are filling up progressively the 3D. Okay, then the next one, that is the 4D series in which we are going to fill up 4D starting from yttrium, 39, zirconium, which is 40, niobium, 41, molybdenum, 42, and then we have technetium, 43, ruthenium, 44, rhodium, 45, palladium, 46, silver, 47, and cadmium, 48. Right? So this is the 4D series. Then we have the 5D series. In case of 5D series, now we also start filling up 4F. So first we are going to fill from lanthanum to lutetium, we fill the 14 elements of F. So the series although starts from lanthanum with atomic number of 57. But from 57 to 71, we first fill up lanthanum to lutetium, and then we come back to the D, right? So we have the next member as hafnium, 72. Atomic number is 72. Then we have tantalum, 73. Tungsten, which is 74. And after tungsten is rhodium, lithium or rhodium, 75. Tungsten, 76. Right? Sorry, tantalum ke baad we will get first tungsten. Tungsten, then lithium, and then after that is osmium. 76, iridium is 77, and then platinum 78, gold 79, and mercury is 80. So this is the 3D series, right? Sorry, the 5D series. Then we have the 60 series, which is not yet complete. 60 series starts from technetium with atomic number of 89. And then after that, the 5F is going to be filled over here from technetium 89 to 103. So this is rutherfordium 104. Okay, so when we were doing the periodic table, we said that up to 104 it has been approved, and after that the numbers, the names are given according to the IUPAC nomenclature, right? So we have then DB, which is 105, and 106 would be written as what? Nil hexium. Hexium, right? And what is going to be the symbol? UNH. This is going to be the symbol. Okay? Then after that we come to 107. Nil septium. So UNS, right? Then is 108. UNO. Nil octium. Right? And then we have Then we have 1110 UUN, near. Okay, and then we have 111 UUU. Okay, and the last one, that is 1112 112, that is UUB. Right? So this is the entire series of D block starting from 3D, 4D, 5D and 6D series. In case of 5D series from lanthanum to lutetium, first we are filling up 57. Similarly, in the actinium series, we are filling up till from actinium to lawrencium, 89 to 103. Clear? Let's go on to the general characteristics of D block now. Next is general characteristics of D block elements. First characteristic of D block element is that they all are heavy metals, with high melting and boiling points. With high melting and boiling points, right? They are very, very hard. Like you know that tungsten, that is the hardest substance known, which belongs to the D block. They are very hard and are good conductors of electricity. They are good conductors of electricity. Then the ionization energy of D blocks is in between S and P, which means that they have higher ionization energies than S, but they have lower ionization energies than P, right? So it is between S and P, okay? Then after that, D block elements. Okay, in this case, we can also write down that there are certain elements like platinum, gold and mercury. These are known as noble metals because of their very low reactivity, right? They are known as noble metals. Then there are the D block elements show variable oxidation states. Like for example, if we are talking of Fe2 positive and Fe3 positive, right? So they are showing variable oxidation states. Similarly, chromium shows Cr3 positive and it also shows Cr6. Okay, manganese show right from +1 oxidation state to +7 oxidation state, and osmium shows the highest oxidation state of +8. Okay, so they all show variable oxidation states except for zinc, cadmium and mercury, which do not show variable oxidation state due to fully filled d orbitals. Right? Then most of the ions of D block elements are colored. This you will study in the next class, in class 12. Colored due to DD transitions. Due to DD transitions. Okay, then most of the D block they are paramagnetic in nature. Okay, paramagnetic means that they are weakly attracted by the magnetic field. They are weakly attracted by the magnetic field, right? And most of them, they behave as catalysts. What are catalysts? They are substances which increase the rate of reaction, which speeds up the reaction, in simple words, without getting consumed themselves. They are not consumed, but still they speed up the reactions, and after the reaction is over, they are recovered as they are. Okay. Then after that, we say that most of the D block have the tendency to form alloys. What are alloys? Alloys are homogeneous mixtures of metals For example, you have bronze, you have brass, you have gunmetal. There are so many alloys which all are formed by or from D block elements. Most of the D block elements, they form covalent compounds, but they have the tendency to form both ionic. They form both ionic and covalent compounds. Both ionic and covalent compounds. Okay, so this is the D block. The last block which is left, that is the F block elements. The next is F block elements. F block elements. Now F block elements, they are also known as inner transition series, and we have already studied that the F block, they are placed at the bottom of the periodic table in two different series, one which is known as the lanthanoids in which we are going to progressively fill up the 4F. Okay, and the second one is actinoids in which we fill up 5F. Right? 4F and 5F. So when we are talking of the general electronic configuration of this, the general electronic configuration is N-2 F 0 to 14, N-1 D 0 to 1 and Ns2. This is the general electronic configuration. Right? So we are saying that the F block elements of two kind, one which is known as the lanthanoids, in which we are progressively filling up the 4F. They are also known as 4F series, and the other one is the actinoids, in which we fill up the 5F. Now you have to remember one thing, that if in case you get a question, lanthanoids are taken into which block of the periodic table, then lanthanoids and actinoids, they both belong to D block. Okay, they both belong to D block, but because they are taken as the first members of the actinoid and lanthanoid series, so thereby we study their characteristics under the F block. Otherwise, according to the electronic configuration, they both are going to come under D block. Clear? Okay. Then let's go on to the general characteristics of F block. The characteristics of F block is quite similar to that of D block. So in that case we say that all are heavy metals. They all are going to be heavy metals. They show variable oxidation states with +3 oxidation state the most common. Okay? +3 oxidation state, that is going to be most common. They all are paramagnetic in nature. As I have already told you what paramagnetism means. They form colored compounds. Okay, they form colored compounds and then they have the tendency to form complexes. So all these, they are sharing similar characteristics with the D block. Okay, now basically when we are talking of actinoids, we say that almost all the actinoids, they are radioactive in nature. And we have already studied that the elements after uranium, they are said to be trans-uranium elements. Uranium has an atomic number of 92. So all those above 92, they are said to be trans-uranium elements. So we have studied the periodic table now, which was put forward by Moseley, okay, and in which he took into account the atomic number instead of atomic masses. There were many advantages of achievements of the long form periodic table, as we have already studied that it gives us the atomic number as the main function of periodicity, which was very well explained on the basis of the periodic table. Electronic configuration had a major role to play when we were putting on all the elements in their proper places, right? So the electronic configuration was also very well explained according to the new periodic table which was given. Now in this, because separation of the subgroups has been taken place, because in the previous table, the Mendeleev's periodic table, there were one had 1A and 1B, subgroup A and subgroup B, right? In this periodic table, separation of the subgroups had taken place, as a result of which the similar elements, they all came together, and the dissimilar elements, they were segregated, they were separated. Okay, so as a result of this, the properties of all the elements could be memorized very simply. The new periodic table was also memorized in a very simple manner. So this was another achievement, right? Then this table is, we say that there is a gradual change in properties when we are traveling from S to P through D. So we just studied that when we are talking of P block, the reducing character, that is decreasing a longer period, and the reducing character is increasing down the group. So all this we have studied very properly. Okay, everything when we are going to study the physical trends and properties in the next section, the periodic table makes it a very easy and very fun-loving study, which we are going to do in the next section. The only two drawbacks which were there in the periodic table was, again, the position of hydrogen was controversial. Okay, because hydrogen has the same problem. It had similarities with the alkali metals and it also had similarities with the halogens. So this cannot again be, it could not be rectified in the long form periodic table. And also the position of lanthanoids and actinoids. The lanthanoids and actinoids were not placed in the main body of the periodic table. They were given separate places. So these are the only two drawbacks. Now in the next section, in the next class, we are going to study the periodic properties and their general trends. Okay?